Hello again, everybody, and welcome to part 2 of the ambiguous case of the sine law video. In part 1, we went over the basics of what the ambiguous case is and how it works. So now in this video, we're going to look at some examples. Example 1. Given each side-side angle situation for triangle ABC, determine how many triangles are possible. Okay, so in the first one here, we have angle A is 30, side A is 4, and side B is 12. So something to talk about here right away is that you notice that these letters match. So in your triangle, I'm just going to draw a general triangle here. If this is A, this would be side A. So really, when your letters match the angle, you know that would be the opposite. And then the way we'll proceed is that we'd say we'll throw B down there. So then side B is here. So that's going to be adjacent to my angle. So we'll make that the adjacent. So in all these examples, the matching letter will be the opposite, and then the other letter will simply be your adjacent. So let's start by, I'm going to draw a little bit of their triangle here. I'm going to get that ambiguous case kind of set up happening. So this is A, like I just talked about, and this is 30. This will end up being 4, but I don't know where 4 is going to meet this triangle, and then this will be 12. Well, if you remember back to video 1, to determine how many triangles are possible, we need to determine the height of this triangle that we're dealing with. So here's my height right here, and that's a 90-degree angle. To find the height, we can use the sine ratio. What color should I use? Let's go back to green. So I'd have sine of 30 equals the height over 12. So now how did I do that? Remember that you have your opposite side length over your hypotenuse. That's how the sine ratio works. And then I'm just going to solve for h. So I'll put that over 1, and I'll treat this as a proportion. It's kind of it's not level here, but that's okay. So h times 1 ends up being h. And then we have 12 times sine 30. Okay, so make sure you're in degrees when you do that calculation. 12 times sine 30, though, ends up being 6. So I know my height is 6. So if my opposite side is smaller, the opposite side is smaller than the height, then that's going to always result in 0 triangles. So in this case, we'd have 0 triangles. All right, let's look at the second one. Again, I'm going to draw this picture. Now, you can't always rely on a picture, but I think when we're first learning, it's good to have something to talk about. So again, I'm just going to draw this kind of general triangle. And that's just kind of to give me a layout for my numbers. Excuse me, I have hiccups. So angle A is 50. Side A is 9.2. So I don't know how long that is really. I don't know where it would meet my triangle. Like maybe this would end up being obtuse or something. But I'll throw it there for now. And then B ends up being 12. And same deal, I got to find that height. Okay, so to find the height again, I'll stick with red. I'm going to have sine 50 now equals the opposite. The opposite will actually be that height over the hypotenuse, which would be 12. And it's the hypotenuse of this right triangle here. Anyway, I'll put that over 1, cross multiply. H times 1 is h. Then I get 12 times sine 50. Again, make sure you're in degrees. That ends up being 9.2, and I guess meters in this case. All right, so now I notice my height is the same length as the opposite side. And whenever your opposite side is equal to your height, sorry, my voice kind of cracked there. Whenever my opposite is equal to my height, then I know I have one triangle. The other way to have one triangle is if your opposite is longer than your height and longer than your adjacent. So let's keep that in the memory banks as well. Okay, third situation, or C. Once again, I'll have my just general kind of setup triangle here. This is 15 degrees. The side A will be 5 again because these letters match. That means this has to be the opposite. Then we'll treat this guy as the adjacent, so we'll throw him here. And again, we got to find the height. Whenever you're determining how many triangles, we have to find that height. Now, we can keep going through that sine ratio, or you can kind of cut to the chase, and it ended up being every single time, it ended up being your adjacent side times sine of whatever angle you're given. So you can jump right to this as well if you want, but otherwise just use the sine ratio and then this will just happen. So I'm going to get 10 times sine 15. Okay, so 10 times sine 15 ends up being 2.6. And so this is my 2.6. And you can see my opposite side, 5, is larger than the height. But then the opposite side, 5, is smaller than my adjacent, 10. So I'll write that out. So my opposite side is greater than the height. And my opposite side is less than my adjacent. Whenever that happens, we get two triangles. Okay, so let's draw these two triangles really quickly, because I think that'll be good to talk about. So the first triangle, I'm going to call it an acute triangle. Well, it is an acute triangle, I guess. So it'd be something like that. And that's my 15 degrees. This is my 5. This is my 10. And then my height is right here. Okay, what I want to really bring your attention to is if I name these, I guess this would be A, B, and C. This angle down here is acute. All right. In the second triangle we can draw, we simply swing this side 5 right here. We just swing it to the left of the height until it meets that baseline of the triangle, and it looks like this then. So here's my A. My side would come down like that. So now I have A, C, B, A, B, C, sorry about that. And my height would end up being over here somewhere, if I was really trying to find that height. And you can see here that this is now an obtuse angle. So this is how they will always work out. This is the situation, people. You're going to have one acute triangle, one obtuse triangle, then that angle I've highlighted, that's going to be the key angle when we start finding things. But you'll see that a little bit later. Okay, D. The one thing I forgot to mention here is that in each of the previous examples, if I go back to C, you'll see here that my angle is 15. It's acute. And in A and B, they were acute as well. I had an angle of 30 and an angle of 50, so they're all acute. So when you remember with the sine law, with the ambiguous case, there is one way to go through it if it's an acute triangle and one way to go through it if it's an obtuse. So you can see here in this one, I have an obtuse triangle. So if I draw my picture again, which is nice just to have a reference point, like I said when we're talking, you don't need to draw a picture all the time, but just seeing I'd have nothing else to show you otherwise. That's 120. Same rule, this is my opposite. So I know 9 is going to be somewhere over here, and this would be my 7. So the deal with obtuse is nice, it's straight ahead. We don't need to find the height. If the opposite is larger than the adjacent, that results in one triangle. And with obtuse triangles, there's either 0 triangles or 1. So really I could just finish this off now. It would look like that. So the obtuse ambiguous case is a lot simpler. There's less things moving on. You really just have to check out the sides. The acute is where you'll see all your work. So the majority of the questions here moving forward are definitely going to be in the acute situation. All right, example 2. It says determine whether each description of a triangle involves a side-side angle situation. If it does, how many triangles are possible given? And then there's some details. So in the first question we just worked with, we knew it was side-side angle. Let's check out the triangles. Truly, when you come across these situations, you won't be given a heads up. You'll just have to notice, oh, that information isn't really clear, so that's ambiguous case, and I can get moving into that then. So now, how do I know if something's ambiguous case or not? Well, there's a couple ways to do it. You could draw your picture, okay, but that pictures are sometimes tough to deal with, so or tough to create. So let's look at that. I'm going to go to blue now again, like I usually do. So I'll have my kind of general setup here. So angle A is 13. I'm just going to complete the triangle. So I'm not going to worry about finding anything right now. That would end up being 2. This is 6. I'm just going to look at the information. So I'm going to call that one B. And it wouldn't matter if I called it, if I would have made the B up here, everybody, where I'll just put a circle. This would still work out, and I guess I can draw that in a second. This is an angle. This is a side, and this is a side. So that means we have side-side angle in this triangle, or ASS, whichever way you want to spell it. Now, you might be wondering, why did I start moving from the A this way, or even say from the S this way, and why didn't I start at this S and go this way, or start at this A and go this way with my naming? So like, why didn't I name it if I started here for a second, A, S, S that way? Well, I guess that would actually still work out to what I was talking about, but I wouldn't go that direction because I have two unknown items in a row. So when you're naming these things, you go until you have two unknowns in a row, meaning that I know my angle here, I don't know this side length, I don't know that angle size, so that means I wouldn't name it in that direction. I'm going to go put some red in here. I know this is getting kind of to be an ugly diagram, guys. But again, now if I start here, and you want to start on one of the ends, I do know this side, I do know this, sorry, that was an angle, I do know that side length. I don't know this angle, but I do know that side length again. So you can see I never had two unknowns in a row, so I know I can go that way. So that is side-side angle, like I said. That's one way of figuring it out. Let me get back to blue. The other way, in my videos, you'll notice I often kind of use this little list idea just to organize and also help me solve these questions, help organize my information so I can make kind of decisions on what I should be using. And if I see, okay, that's 13 degrees, this is 2, and this ends up being 6. Well, whenever you do this kind of setup, whenever you have your sine law situation, so we have the full row, and then that you're given, sorry, one of those other sides, then we're going to know that we're in side-side angle as well. Okay, so there's two ways to do that. The second method might be the easier way, but you might like drawing pictures. Okay, so the second part, it says if it does, how many triangles are possible? Again, okay, so I guess I'll make this step 3, although it's not really step 3. So let's cross that out. Let's just go a different color. I want to know the height, and remember, I said different color. No, oh my gosh, it happened again, you guys. Okay, looks like it's red. All right, that is definitely red. Anyway, to find the height, we can go the adjacent side times sine of whatever angle you're given. Okay, so the adjacent would end up being the 6, and from sine of 13 degrees. Okay, so then I would get 1.3, and that, what's my unit? Centimeters, it looks like. Okay, based on that, my opposite side is larger than the height, but then smaller than the adjacent, so there'd be two triangles there. So two triangles in this situation. And why? I can write that out. Opposite is larger than the height, and the opposite is smaller than the adjacent. Okay, it doesn't say we have to draw them, just kind of make note of how many there would be. Okay, in this second part, it says in DEF, angle D is 89, side D is 14, angle F is 11. So again, I'm just going to give myself whatever triangle here real quick. Well, I'm saying this is 89, but you can see that's less than 89. I'll call that D. I'll call this one F. So other D would be, side D would be there. This would be my angle 11. And if I name everything, let's use red here. So this is an angle. This is an angle. And this is a side. So it actually had to be angle, angle, side, this one. So this was not angle, side, side, or side, side, angle. So this is not SSA. So I won't go any further than that. But you can see, so not every triangle you see will be an ambiguous case. Okay, example 3. Martina and Carl are part of a team that is studying weather patterns. The team is about to launch a weather balloon to collect data. Martina's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Carl's rope is 5.9 meters long. Period. I don't know why I used that inflection like that, like I was going to keep talking. Anyway, assuming that Martina and Carl form a triangle in a vertical plane with the weather balloon, meaning, assuming it looks like a triangle when we get to the side and look at these people, what is the distance between Martina and Carl to the nearest tenth of a meter? Okay, so again, I like to draw a little bit of a picture here just to give myself something to look at as I'm working. You You might not like drawing the picture, so I'll show you something else you can do as well. I've already shown it to you once, actually. It's that list method. But I think really it's important to try to kind of put something down here as a visual. So we got Martina and Carl, and they both have ropes that are kind of belonging to a balloon. So I'm going to go like this, and I'll say this is Martina, this is Carl, and this is the balloon. So it says Martina's rope is 7.8 meters. 7.8. It makes an angle of 36 degrees with the ground. Carl's rope is 5.9, so this is Carl. Assuming that Martina and Carl form a triangle, so I can see there's a triangle, what is the distance between Martina and Carl? So we're looking for this. So truly, this, I mean, I don't, you can definitely do this list, which I'll do right over here. So angle M, angle C, angle B, but I think it'd be pretty tough to put the numbers in without having that visual. But if you can do that, if you can kind of picture this stuff in your mind, that's great. So go for it. Anyway, that would be 36. Side M is 5.9, and then side C is 7.8. Okay, so when I look at this picture, hopefully that kind of looks familiar. Like that looks like it's angle side side to me, and I can see angle side side. So I know, well, this is ambiguous. There might be 0 triangles possible, 1 or 2. Now, it looks like at least 1 because this triangle seems to make some sense in my picture. But to determine that, we just have to go through our height calculation. So I'm going to do the height calculation actually up here. Okay, so this is the first thing I have to do is really check my height. So it's going to be my adjacent times my sine of whatever angle. I forgot when I get this close to the borders of my laptop, my pen doesn't work very well. So anyway, it's going to be 7.8 times sine 36. Make sure you're in degrees, everybody. And then I get 4.6. Okay, so the height here is 4.6. Okay, well then maybe it's unfortunately my opposite side is greater than the height, but then less than the adjacent, meaning 2 triangles are going to be possible. So I'm going to have a triangle like I have here. Okay, my acute one. This is going to be acute right here. And then I'm going to have a second obtuse triangle where this angle here is going to be obtuse. So both of these situations, 1 and 2, make sense in theory, but really only one of them will exist. So when you like presented your answer to the people who were wondering, they'd say, oh yeah, Martina and Carl were on the same side of the balloon, so it's more like situation 2. Or you can say, oh no, they're on opposite sides of the balloon, so it's actually like situation 1. In math theory, both make sense, but in the real world, only one of these situations actually happens. So, but we're just presenting both situations because we're not there. We don't know what is the proper situation. Okay, so let's look at now the acute. So part 2, we're going to look at this acute triangle. Okay, and we've already got all the information right over here. So what I want to find is I want to find side B, but to find side B, I guess I would need to know angle B. Well, I don't have either of those. But if I could find angle C first, I guess I could find that because I have my row. I have my row here. Okay, and I can use this one, the second row, to find angle C. Then I could find angle B, and then once I find angle B, I can then go to side C. So that's going to be how I do this. Okay, so let's get going here. All right, so first of all, I'm looking for this angle C. So it's going to be sine C over 7.8 equals sine 36 over 5.9. Cross multiply. So I'm going to get, I don't really need to cross multiply. We've talked about this in my other videos. Whenever you put what you want in the top left, you don't need to do this cross multiplication. You can be kind of lazy and just do a single kind of like half cross multiplication. So, well, I guess I could have left that actually. Sine C equals 7.8 times sine 36 over 5.9. And then I want angle C, not sine C, so I have to take the inverse of that. just rewriting what I had as a fraction there. Okay, so angle C ends up being, when I calculate that, 51.0. All right, we're going to go to the nearest tenth. So that's my angle C, 51.0. Maybe I'll write that in red here, 51.0. So that was good. Now I can find angle B. So the way we find angle B is I'm going to go 180 minus those two angles that I know. So I know one of the angles is 51, the other one's 36. So that ends up being 93 degrees. Okay, and then now that I have that, now I can actually find what I want to find, which was angle, sorry, not angle, but side B. So that'll be sine 93 equals 5.9 over sine 36. And again, I put what I wanted in the top left so I can kind of be lazy. And I can go just B equals 5.9 times sine 93. Again, for those people who haven't seen my other videos and you're like, why in the world can you do that lazy cross multiplication? It's just because I'm taking advantage of a pattern. I know that this it'll be B times sine 36, but I don't want sine 36 and B to be together, so I have to move the sine 36 away from the B. I'll do that by dividing, and what happens is you move sine 36 right back into its original position. So if you do a full cross multiplication, you move sine 36 and then move it right back to where it was. So seeing if you know that pattern, you don't have to move it initially because it doesn't change anything. Anyway, now I would write out that side B, which is the distance that Martina and Carl are apart. And that's my first answer. Because remember, this was my acute triangle. So now we have to solve it for the obtuse. So, important thing here. Actually, not important thing here. Let's flip to the next slide, and then I'll do it. Okay, so I can't remember my numbering. Let's say it's 3, and this is my obtuse. So I'm going to draw this picture again. So what I'm saying now is that Martina and Carl, and here's my balloon, they must be on the same side. So again, this was 36 degrees. The rope was 7.8, Martina's rope. Carl's was 5.9. So this also makes some sense. So that's why we have to solve for it, because this is possible too. So again, I'm going to make my list. Helps for organizing, and also helps make decisions. Oops, that's C, and this is B. So that's 36 degrees. Side C is 7.8, and side M is 5.9. Okay, we have the exact same thing, or setup, where I have to find side B. But to find side B, I need angle B. And then to find angle B, I actually need side C. So here would be the first thing I find, the second thing I find, the third thing. Okay, so when I do this calculation, I'm going to be looking for sine or angle C first. So I'd have sine C over 7.8 equals sine 36 over 5.9. Do my lazy cross multiplication. Sine C equals 7.8 times sine 36 times 59. And then I want actually angle C, so I have to take the inverse of this, which simply means I have the value, I have the decimal value, I want to know what angle is associated with it. Your calculator is kind of programmed to go from you tell it the angle and it'll tell you the value, the decimal value anyway. So inverse meaning really we're just going to be going backwards on our calculator, telling our calculator to go backwards. Okay, so when I plug that in, I'm going to get 51 degrees again. So I say again because if you look back on the previous slide, and I'll let you do that yourself, you'll see that you get 51. And why do you get 51? Because this is the exact same value. So I did the exact same calculation. So if I look at angle C, I can see here that's obtuse. So there's no way it can be 51. So what's going on? Well, hopefully you remember that with sine, it'll always tell you it always tells you an acute angle. So the information required to use the sine law, it doesn't differentiate. It can't determine if you're dealing with an acute or an obtuse triangle. So it'll always spit out these acute angles. And then what you have to do is make our little adjustment, which is simply subtracting your given angle 51 from 180. And then I end up getting 129. So that's going to be my answer for angle C, 129. So even though I had the same setup, I am getting this different answer because it's an obtuse triangle. And then now I can kind of work through like I did before. So angle B, which would be 180 minus those two angles I know, so 129 minus 36. That ends up being 15 degrees. So I'll punch that in here too. And then now I can find this side B. So side B over sine 15 equals 7 point, well, it doesn't really matter which one. I guess I use 7.8 there. 5.9 is what I want to use. I always try to use my givens whenever I can. So sine 36. And I'll do my half multiplication. So B equals 5.9 times sine 15 over sine 36. And I end up getting 2.6 meters. So depending on the situation that is drawn up, we have two answers. We would say that Martina and Carl are either 10 meters or 2.6 meters apart. So again, only one of these answers will be true in real life, but in math theory, based on what the information they've given us, we actually have two valid situations that it could happen. So Martina and Carl either were standing on opposite sides of the balloon or they're standing on the same side of the balloon, and we have an answer for both cases. So that's how you'd use, that's a problem that uses ambiguous case. Here's an extra slide in case. Leanne and Carrie are hiking in the mountains. They left Leanne's car in the parking lot and walked northwest for 12.4 kilometers to a campsite. Then they turned due south and walked another 7.0 kilometers to a glacier lake. I am sorry, guys. I got hiccups. It's just killing me while I'm reading here. The weather was taking a turn for the worse, so they decided to plot a course directly back to the parking lot. Carrie remembered from the map in the parking lot that the angle between the path to the campsite and the path to the glacier lake measures about 30 degrees. How far would Leanne and Carrie need to travel to reach the parking lot? Okay, so we got the situation. A lot of language there, right? A lot of words, but they're trying to describe a real life situation, and it takes words to do that, right? So let's start working on this. They're in a parking lot and they walk northwest for 12 kilometers. So parking lot northwest for 12 kilometers. So got to use my directional headings here. Whoops, that didn't go through my dot there, but you know what I'm talking about. So northwest, so again, this is north, never eat shredded wheat. So we know they're just going northwest, so I'm going to say it's like that. And they go for 12.4. They then turn due south and walk another 7. So due south is straight down, everybody. So I'll say due south, and that's going to be 7. Yeah, and then the weather is taking a turn for the worse. So I decided to plot a course directly back to the parking lot. I'm going to make this a little bit longer so it doesn't look like it's a right triangle by accident. Okay, there's my triangle. Carrie remembered that the map, the angle, but so I'm sorry, I'm being a bit scattered here. Here's my parking lot. This is my campsite, and then maybe I'll put a P here. Sorry, this will be a P, and this will be my glacial lake. And okay, so Carrie remembered from the map in the parking lot that the angle between the path to the campsite and the path to the glacial lake measures about 30 degrees. So here are my paths. So, and they're differing by 30 degrees, so that would mean my 30 goes right in there. Okay, so that is my situation. Now, again, if I look at that, that looks kind of familiar. Looks like that'd be an angle, that side, oh darn it. It's ambiguous case, people. Who would have guessed an ambiguous case question in the ambiguous case video? So again, once you know it's ambiguous case, you need to do that height calculation. I guess like here could be my height kind of thing. So we know how to do that. Again, I don't have a lot of room in this slide, so I'm going to do the height up above. So the adjacent times sine of the angle they gave you. Adjacent would be 12.4 because the other one would be opposite. And then times sine 30. Okay, that ends up being 6.2. And that means my opposite side is 7. So, oh gosh, the opposite is larger than the height. And the opposite is smaller than the adjacent. So that means there are 2 triangles, people. 2 triangles. So it's going to be similar to the previous question. A little bit different, but it's similar that there's 2 triangles. So the first one will be this acute triangle. Okay, and it looks like I always find the acute first. And the reason I find the acute first is, remember, sine law always by default just gives you the acute. So that seems like, for me, that a good enough reason to always do my acute first. And the one I drew is acute. I shouldn't say technically, I just naturally draw acute triangles all the time when I'm doing my situations. I don't know if that's everybody does that or just me. But so that is my triangle, so I can fill in this list because, again, I like to. Whoa. Side C, side L, side P. So angle P is 30 degrees. Side P is 7. And then that'd be side L, which would be 12.4. And again, you can see here's my row, so I know it's sine law. And then there's my other side. So whenever you have the full row on another side, we know we're in this ambiguous case. Now, I am looking for how far would Leanne and Carrie need to travel to reach the parking lot. Okay, so just to remind you, they start at the parking lot, and then they go to the campsite, then they go to the glacial lake, and they want to go back to the parking lot. So we're looking for that there. That's going to be C. Oops. That's going to be side C, sorry. So I'm going to need side C. To get side C, I'll need angle C. And then to get angle C, I'm going to need angle L. So yeah, unfortunately, it's the exact kind of same situation. I was thinking this was actually a little bit smaller, a quicker problem, but it's not. But that's okay. It's not like they're that long, really. It's more determining how many triangles. It kind of makes it tougher. So the first thing we're going to do is we are going to find this angle L. So sine L over 12.4 is going to equal sine 30 over 7. Now, I don't have a lot of room, so I'm going to combine my steps. To find angle L, it'll always be the inverse of this cross multiplication. So 12.4 times sine 30. So typically I do this in 2 steps in my videos and on the board. But if you're tight for room like I am, you can just do it in 1 step there. So angle L ends up being 62.3 degrees. Let's write that in. 62.3. And this angle here, that's always that big one. So that's acute for us. That's that'll pop up in the next triangle as well, but it'll be obtuse. Okay, so that's angle L. So now I need angle C, which will be 180 minus 62.3 minus my given angle, which is 30. So 87.7. Okay, and then now I can find side C. So C over sine 87.7 equals 7 over sine 30. So C is equal to 7 times sine 87.7 times sine 30, which will equal 13.98. It's 13.98, so we're going to round to 1 decimal place, so I guess that ends up rounding to 14.0. And what was our units? 14.0 kilometers. Well, they got quite the trek there yet, don't they? Okay, so that was for the acute. Now we can go to the obtuse. Okay, so for the obtuse, what I can do is I can redraw this. And the reason this one works like this is because they say northwest, they don't say how northwest, how much. So if I go like really straight up like that, and then my straight south, and then over, that would be an obtuse triangle that's still following the rules. So again, here's my parking lot, here is my campsite, and here is my lake. So this would be my 12.4. I wrote that kind of funny. This would be 7, and this would be my 30. So angle P, angle C, angle L, PCL. That's 30, 7, 12.4. You can see I have my my whole row and another side, so that's that ambiguous case sign. And again, I want to find, I really want to find this side C right here, but I'll have to find this guy first. Oops. Yeah, first, and then this guy second, and then I can find my side C third, just like that other triangle. So that's kind of often a procedure. The other thing that can happen is you don't need to find everything. Like sometimes maybe it was just angle L we had to find, but we had to find it for both triangles. So don't think that you have all this work every single time. Anyway, let's get going, because I know time is precious to you people, and I appreciate you watching the video. So sine L equals 12.4. Oh, I know. You're welcome. You appreciate me making the video. I get it. Anyway, sine L over 12.4. Sine 30 over side length of 7, sorry. And again, I'm going to be kind of lazy here, people, and I'm just going to write it in that shorter version. So instead of having sine L is equal to my fraction, I'll have angle L is equal to the sine inverse sine of this fraction. So 12.4 times sine 30 over 7. And again, it's going to spit out this angle 62.3. Now, what you can do is you don't need to go through this. You can just remember from the first triangle, hey, that first angle was 62.3, and when I do the second calculation, I have the exact same fraction. So you can just directly go to this, go, okay, well, this second angle, L, would have to be 180 minus 62.3 because it has to be obtuse. So that 117.7, and that's would be right there. I'll highlight it right here. So again, you can just kind of go right to this. If you want, by all means, do the calculation again. It doesn't hurt you. But if you want to save some time, if you can remember what's going on there, by all means, use that. So anyway, that was angle L. Then I got to find this angle C. So angle C is going to be 180 minus 117.7 minus the 30. So 32.3. And then now I can find, I guess I can fill these values in. So this is 117.7, 32.3. And then now I can find the side C. So C over sine 32.3 equals 7 over sine 30. Oh my gosh, we're almost done, people. Thanks for bearing with me here. It's been long. C times the sine over sine 30. So 7.5. So that would be my second possible answer. And again, you'd present both of your answers, and then whoever was actually in the situation could say, oh yeah, no, it was more like this one. Not again, because both answers didn't really happen, only one happened, but both make sense in math theory. Okay, you guys, so that's a pretty thorough video on how to get through this stuff. It's not bad at all. The solving, there's nothing new with the solving. Just remember that you don't really need to find that angle L like in this example twice. One of them will be acute, and the second one you can just go 180 minus it. But yeah, the rest of the solving is pretty straightforward. It's just, can you determine how many triangles, so remember to find your height. If it made sense, that's great, and if it didn't, make sure you come talk to me or your teachers. Otherwise, have an awesome night, everybody.